So we need to find the interval of convergence. Let's compare this series with its standard form, which is the sum of -1 to the power of n times an times x to the power of n, where n goes from 1 to infinity, and we get that in our case an equals 1 over n. So we can obtain the radius of convergence by the following formula. So the radius of convergence equals the limit of an over an plus 1, where n approaches infinity. This equals the limit of 1 over n times n plus 1 over 1, where n approaches infinity. So this equals the limit of n plus 1 over n, where n approaches infinity. This equals the limit of n multiplied by 1 plus 1 over n, where n approaches infinity. So this equals the limit of 1 plus 1 over n, where n approaches infinity. Since n approaches infinity, then 1 over n approaches 0, then this equals 1 plus 0, so just 1. So we get that the radius of convergence of this series is 1. So that means that the series converges for all x which are less than 1 and greater than -1. But now we need to check the endpoints. So at x equals 1, the series becomes the sum of -1 to the power of n over n, where n goes from 1 to infinity, and it's convergent. And at x equals -1, the series becomes the sum of -1 to the power of 2n over n, where n goes from 1 to infinity. So this equals the sum of 1 over n, where n goes from 1 to infinity, and this is divergent. So we get that our interval of convergence looks like this.